everyone, and welcome to this session about micro-frontends and patterns. My name is Luca Mezzalira. I'm a principal solution architect at AWS. I'm an international speaker and an O'Reilly author. I would like to start with a bit of history, just to recap where we are nowadays with micro-frontends. So the first appearance of micro-frontends, or micro-apps as they were called, was in 2015. 2015, we have seen Tailor.js that was part of a larger framework called Mosaic 9 that was released open source by Zalando, the fashion e-commerce. Tailor.js was a UI composer where it was retrieving multiple HTML fragments, composing them and serving to a user. That was the first implementation of micro-frontends, despite the name wasn't yet there. In 2016, micro-frontends shows for the first time inside the technology radar made by ThoughtWorks. The interesting part here that they are suggesting to assess this specific architecture in order to understand and see if the benefits of microservices were applicable also on the front end. After a few years in 2019, we started to see a rise of micro-frontends. Probably 2019 was the first year where finally we can start to see a lot of companies embracing micro-frontends. As you can see from these slides, we have quite a few of them that were using micro-frontends in production. And in 2020, micro-frontends were inside the architecture and design repo from InfoQ, where they describe micro-frontends as embraced by innovators alongside many other technologies. It's very interesting that at this time, micro-frontends as a modular architecture was at the same category of data mesh. That is another way to modularize your data when we are talking about managing data from multiple teams and in multiple domains. In 2021, I would call that was the year of discovery. In fact, more companies are embracing micro-frontends, and there are new learnings and new trials, new discovery in general of best practices on how to embrace micro-frontends. So far, what we have learned on micro-frontends is that they are great for incremental upgrades. We can take a slice of our domain or application and iterate on that and slowly but steady implement new functionalities without impacting the rest of the application. We have a decentralization concept where we start to have teams that are responsible to take decisions, and they are responsible also about their own future. That is a very interesting concept, because if before with monolithic architecture, we had architects and tech leaders that they were taking their own decision for the entire platform, here every team is responsible to follow some guardrails provided by the tech leadership, and but they have also in power to take certain decisions inside those guardrails. There's also a reduction of cognitive load for the team, where instead of being aware of the entire application, they became domain expert inside their area. And finally, it's a good way to scale the technology as well as the organization. Like microservices, for instance, we are creating a distributed system that is not only solving a technology problem, but also an organizational one, because we create independent teams that they can take their own decisions inside certain boundaries. One thing that we learn in Amazon is that there is no compression argument for experience. That is what our CEO often are telling us in many of the all-hands sessions. And I fully agree with this approach, because what I have learned is when you are experiencing this implementation and you see how implement, in this case, micro-frontends, you discover a lot of things. What you're going to see in the next few slides are example of experience that I was involved to, and it's not only, let's say, potential things that happen, are situations that really happen, and use cases that really happened to me, and we found a way to overcome them. So let's start with the first anti-pattern, the yin and the yang, or the difference between micro-frontends and components. So the first one, let's talk about component. A component is potentially this button. And in this button, what we can do is defining a label. And that is very normal for a component. But then, moreover, the product evolves, and this button start to have also the possibility to set up an icon. So now we can set up the icon and the label. Moreover, there is a new requirements where on a specific area of our application, we want to have a different border color of this button. And then we want to set up a different rollover animation. Therefore, the button incorporate both of those changes, and we can orchestrate them from the container. Then we decide that because of internationalizations, we can have an auto-size dimension, because we know by upfront that certain languages require more space than others. And therefore, we need to figure out the logic that allows us to do so. And finally, there are some area of the application where we want this button that is disabled by default till the user is interacting with a specific form. So as you can see, there are different state and different properties of this button. And this button is encapsulating all these things. But the reality is that the button is fully managed by this container. And that is what a component is. There is an extensibility characteristic that is intrinsic about this component. Let's see how a micro-frontend would work. So first of all, let's define what a micro-frontend is. Micro-frontend are a technical representation of a business subdomain, allow independent implementation with same or different technology. We minimize the code share with other subdomains, and finally are owned by a single team. So on this definition, I think there are two things that are quite key to understand the difference between a micro-frontend and component. The first of all, micro-frontends are a technical representation of a business subdomain. So if we're familiar with domain-driven design, this is just a portion of an entire system. And that's very important because they are not solving a technical problem, but they are instead showing how a business domain should be rendered. And more importantly, they are independent implementations. So there isn't a container that should orchestrate or even provide too many properties that are changing the way how the micro-frontend works. That the logic on how the micro-frontend should work is based on the domain, and therefore they are fully encapsulated. So a micro-frontend in this case is independent, so we can independently deploy a micro-frontend and we don't need to coordinate with other part of the system. They are domain aware, so we don't have to inject certain information in order to make the micro-frontend behave in a different way. That is something that if the micro-frontend should behave in different ways, it should be the micro-frontend itself to retrieve the information related to its context in order to behave. And therefore, the container itself became a laying container, a dump container, where we have a container with that is just loading multiple micro-frontends, and that's it. It shouldn't be aware of the different domains that are loaded inside itself. For communicating, a micro-frontend is usually defining the input and output. Vast majority of the time, the communication between micro-frontends is happening following the pub/sub pattern. Therefore, an event emitter or custom events or even a reactive stream are all good ways to communicate between micro-frontends. And finally, micro-frontends are not extensible. As we said, they are domain aware, and therefore the only thing that usually we can inject inside the micro-frontend is in the case of the event emitter, the instance of the event emitter, but we are not going to provide properties and other information that will make the micro-frontends reactive. All the logic of that will be encapsulated inside the micro-frontend. So usually when you understand deeply the difference, you don't end up with a situation like this, where you go very, very granular and you say, oh yeah, I have tens of micro-frontends in my same view. There is more often than not the possibility that when you end up in a situation like this, you are dealing with components. Therefore, the granularity that you have is not the right one. You should go back to the whiteboard and make sure that you are dividing your application with multiple micro-frontends and not components. Second anti-pattern is the Hydra of Lerna or the multi-framework approach. More often than not, I have seen many people thinking that micro-frontends are a way to deal with multiple UI frameworks. And despite that you can, it doesn't mean that you have to use. For instance, how many of you would use in a single page application multiple UI libraries? Maybe Angular with React or Angular with Vue.js? Probably the answer would be none of you or not many, because definitely there are a performance implication on introducing multiple UI libraries, but moreover, it wouldn't make any sense because you risk to have not only the UI library, but also other libraries related to a specific framework or the UI library, like the state manager, for instance, just to name one, that are dedicated to a specific thing. So your bundle size starts to grow, and it's possible also that there could be some runtime clashes. So in a multi-framework approach with micro-frontends is true, it's possible, and there are situations where it's very, very important using it. So for instance, when we are dealing with a legacy system and we want to migrate from an existing system to a new system, using this approach is definitely a good way. And also when we are migrating from the same framework or we want to migrate to a new framework, and we want to migrate to micro-frontends, using for a certain period of time multiple UI frameworks is something that is acceptable, because you know that is a temporary change, and despite you are creating and causing potential issues on downloading more code at the beginning for your customer, you know that at the end this will pan out well, because you know that you are migrating for a small amount of time. And finally, when you are acquiring new companies, if you want to integrate the software from the acquired companies at your application, using micro-frontends with a different stack is definitely something that is doable. I think there are these three scenarios that I have seen useful, the concept of multi-framework, but more in general, if you're starting a greenfield project, don't start with the idea of, I want to integrate multiple frameworks, because you will have some performance penalties. Another anti-pattern is that Swiss Army knife, or write programs that do one thing and do it well, like Unix taught us in the past. So imagine that you have a greenfield project and you have your application shell, that is the dotted line, and the application shell is loading one micro-frontend. Then you, after a while, you think, okay, but I cannot load just one micro-frontend per time. On top of that, where it's covering vast majority of the scenarios, I also need to have multiple micro-frontends in the same view. Not many, because we recognize that are micro-frontends, but the application shell should be aware that should load not just one sometimes, but also multiple micro-frontends. So in that case, then you define the communication between micro-frontends when they are in the same view, and also how to communicate between micro-frontends in multiple views using local storage, for instance. And the application shell is also responsible to load micro-frontends via system.js. Therefore, every micro-frontend's entry point corresponds to a JavaScript file. This is the decision that you have made in your greenfield project. But suddenly, what happened is that you are, a new request is to embed the legacy editor or the legacy application that is available, and you want to create a compelling and cohesive experience for your user. Therefore, you want to integrate this editor inside your micro-frontends implementation. Now, the problem is your teams have no clue on how the editor works, and they don't want to risk to manage that inside in the same way how they handle the micro-frontends. There is no way that they're going to rewrite from scratch because it would take too long. And therefore, the idea is creating let's say a micro-frontend that has a container that acts as an anti-corruption layer. So that means basically that the legacy editor, in order to avoid the clash with the rest of the application, could be loaded inside an iframe. But because your application shell communicates using, for instance, even the meter and local storage, we can sanitize, if you want, the iframe implementation of the legacy editor, wrapping it inside a container that is basically acting as a translator from the communication between the iframe to the rest of the world. That provides a nice way to decouple the legacy application with the new greenfield. Is also providing an alignment on the architecture decision, because you don't have to use post message like you would use for an iframe, but you will use the way how you use to communicate with the rest of the application. And finally, if in the future you will have time to rewrite from scratch that specific editor, you don't have to rewrite the application shell that should be able to communicate with iframe and load an iframe and the rest of the application that is greenfield, but you have an application that can be removed and replaced very quickly with a brand new micro-frontend that iteratively can be deployed and replace slowly but steady the entire legacy application. This is a great approach for handling this scenario without compromising in a cohesive API specification. Another one is the return ticket or the unidirectional data flow. I think you are familiar with Module Federation, and one thing that is a Webpack plugin that was released with the Webpack 5 and is available also with Angular. And one of the beauty of these or the capabilities of this fantastic plugin is that you can lazy load specific application or remote bundles inside a host or a container. And that is nothing wrong with that. I think is a great implementation. Is taking care about the undifferentiating heavy lifting for you, so you don't have to let's say take care about clashing with dependencies or how to load specific micro-frontends. The only thing that is not always working as expected is that you can have a bidirectional sharing between micro-frontends. In this case, the host can share something with the remote and vice versa. In the past, we have learned that this bidirectional communication is not a great ally for developing application, especially when you work in multiple teams. Unidirectional data flow is a concept that is very well known in the industry. I remember when, for instance, for the first time, I have seen Flux, that was a framework that was leveraging the concept of unidirectional data flow. And the idea is that basically you have only one flow and a way to understand how the data are moving from one step to another one. After Flux, there are other architectures that started to use the same concept. For instance, the model view intent that was created a few years ago, and it was present in JavaScript with Cycle.js, but also now is embraced on native Android application. Leverage the same concept where you have a user interaction that is communicating with their intent. For instance, they click a button for submitting a form, for instance, that will update the model. The model will load a new state, and then the state will be rendered in front of the user. This unidirectional flow is another way for handling that. And those are just some examples on how unidirectional flow started to raise inside the front-end community. The important thing of unidirectional data flow are the first are easy to debug. It's predictable. I know exactly what to expect the next time when if something is not working. If I know exactly how to debug my application, because for instance, if I know that in the previous step I had the right data, and the next step I don't have the right data, so probably something is happening in between or in the second step. And also it's less prone to errors because once again it's very predictable, and therefore I can understand that very quickly. This is very important. So when you're using module federation, but not only with module federation, also when you are creating your custom implementation, bidirectional communication between the container and a micro-frontend can cause more problems than not, especially when you work with multiple teams. Remember that what we are doing here is creating a distributed system on the client side, and therefore it's very, very important that we try to minimize the coupling between systems, because otherwise we risk that we always deploy together and we end up having a distributed monolith that is the worst of the both worlds. Another anti-pattern is relax, just code, and or how to avoid organizational coupling. One thing that I have seen quite often, especially for teams that are embracing micro-frontends for the first time, that they have a situation like that. They have multiple micro-frontends with multiple teams that are taken care of, and then they start to create a global state where everyone is writing there. The problem with this approach is that now we are coupling the teams, because if micro-frontend A that is creating a new variable that is used by also other micro-frontends inside the global state, that means every time they change something, maybe they move from an object to an array or whatever it is, they need to coordinate the change across multiple teams. And basically we are breaking the independence of micro-frontends, because we are coupling them not only at the technical level, but also, and more importantly, if you want, at the organizational level, because every team has to be responsible for that. This is quite common, and trust me, there are easy ways to fix that. That, for instance, is introducing the concept of the event emitter, a pub/sub pattern that basically allows you to decouple the communication between micro-frontends is the way to go. So in this case, if you have multiple teams working with, let's say, together in the same view, and we want that micro-frontend A notify the others when a specific state change inside his own micro-frontend, they just need to use an event emitter, dispatch the event, and in that case, who is interested to that specific event will react to it. And that is great, because it means that if tomorrow we have other two micro-frontends that has to behave or react onto a specific event, they just need to implement inside their own domain, so encapsulated basically inside their logic, the behavior of that specific event when it's triggered. And also in the future, we can evolve these very quickly. The only thing that we need to do is creating a good documentation and notifying that there are notifying that there are in the wiki all the input and the output of a specific micro-frontend, so every team can be aware on how to interact with your micro-frontend. Finally, the last anti-pattern is let's armor the APIs. And one thing that I have seen is sometimes the granularity is very deep, and the nesting also can be very deep of micro-frontends in the same view, and therefore we end up to have multiple micro-frontends calling the same API. So imagine, for instance, this scenario that we have this very simple grid with multiple micro-frontends, and the two micro-frontends at the bottom are calling the same API. Now, what does it mean for the backend? So let's imagine that those two micro-frontends are calling an API. The first thing that in a distributed systems of microservices, we will have is an API gateway that is a central point that exposes all the APIs. Your API are also under authentication, therefore the micro-frontends are passing the JWT token. The API gateway is triggering a central authorization service, and then after they are authorized, they call the API 1. But it's a microservices implementation. You don't have the guarantee that this API 1 will be sufficient to reply to all the micro-frontends. So in that case, you have API 1 that is calling other APIs. And therefore, if before we plan to have just one API call, in reality here we have multiple API calls because the nature of the distributed system. Now, it's okay if you have 10 requests per second, maybe, and in this case, you're going to have 20. But the problem comes when you start to have a million of requests per second, or a million requests per minute. And if you have two or multiple micro-frontends in the same view that are calling this API, you can create a cascade effect and de facto potentially create a DDoS attack to your same system. And that's not great only for the risk of doing so, but also for the cost of the infrastructure that is going to rise inevitably, because now the API one, the authorization service, and all the other APIs that are bundled together for replying to all the micro-frontends has to scale for that level of throughput. This is definitely a big deal, because you are basically risking to complicate your infrastructure just for the sake of too much granularity, because maybe you didn't spend enough time defining your boundaries. So there are a couple of solutions for that. The first one is maybe go back to the whiteboard and start to see if those two domains are really two separate domains. If they are consuming the same APIs, it's very likely, in my experience, that you have potentially the same domain. You just go to granular and maybe you confuse components with micro-frontends. The other approach is if you really need to have separated teams taking care about that, using components inside a micro-frontend. So you have a container of micro-frontends that is really making the call. One team is responsible for that container and maybe one component, potentially both components, but it's not always possible. So maybe let's assume that one team is responsible for component A and the container, and another team is responsible for component B. So in that case, it became easier because, as we have said before, you create an extensible, let's say, element or entity that will allow the micro-frontend to inject information in, and therefore the domain is not leaked in the rest of the application, and we will load just one micro-frontend per time. That are some of the anti-patterns that I have seen so far. Bear in mind, the architecture is always a trade-off. There isn't right or wrong. As you have seen, we are suggesting certain solution based on specific context. But remember that you need to really understand the context before you can take a direction that fulfill your needs and your architectural characteristics. Thank you very much for your time. I hope that you enjoyed the talk. And if you have any questions, feel free to reach me out at that email that you can find at the bottom of this slide. Enjoy the rest of the conference.
Hi, I'm Joe Weems. Thanks for checking out this video from EnterpriseNG 2021. Online conferences were great, but it's time to get back in person. See your old friends, make some new ones, and take your career to the next level. Head over to ng-conf.org to get your ticket. See you there.